Okay, this is concept number 4, which is solving systems of inequalities by graphing them. Now, when we solve these, it truly is the same exact steps as the last pretest. So it's number 3, where we just graphed a single inequality and shaded it. Okay, so you're still going to do those same steps. The only difference is now, instead of just having one inequality on the graph and shading in one spot, you're going to graph a second inequality on the same coordinate plane and shade it as well. So it's 2 problems, just like from pretest number 3, but you're doing them on the same exact coordinate plane. So it's the same exact steps. So you start by graphing the inequality. Okay, again, if it's less than or equal to, greater than or equal to, it has a solid line because of the equal to sign underneath of it. If it's just a less than or just a greater than, then you use the dotted line. So exact same steps as the previous pretest. Now, you still have to shade, so you're going to need to pick a test point. You have to shade for both of these lines. Where their shadings overlap is the final answer. Okay, so you're looking to see where both of these lines are shaded at. So it's where they overlap. Okay, but it's truly the same steps as before. There's really nothing new here other than you have 2 of them on the same graph. Another hint here is just any point in your overlapping shaded region should make both of the inequalities true when you plug it back in. So a really good way to check your final answer is to pick a point out of that double shaded region where they overlap at. Pick any point that falls in that area and plug it back into both of the inequalities to make sure that it makes them both true. Now, first example. So we have 2 different inequalities. Okay? First, I have the inequality that's in red, which is y is less than or equal to 3x minus 6. I have a second inequality that's in blue, that is y is greater than negative 3/4 x plus 3. Okay? So we're just going to start by graphing this first inequality. Now, it's already in slope-intercept form, so you have no rearranging to do first. You could just go straight to graphing. Okay? Remember, your slope is 3, your y-intercept is a negative 6. So you start by plotting the negative 6 on the y-axis. So we go down to negative 6 and plot a point. Your slope is a positive 3. Remember, to make that as a fraction, it's 3 over 1. So you go up 3, right 1, up 3, right 1, and keep plotting your points. Okay, so it's exactly the same as the last pretest. You're going to plot your points using your slope. Once you get that line graph, now you have to pick a test point for this line. Again, same as last pretest, easiest one to use is 0, 0. So here's my test point of 0, 0. When we plug it in, we get a false statement. Okay, so 0 is less than or equal to negative 6 is not true. Because this test point is false, I want to shade on the opposite side of the line. So all of my red shading is over here. That one's done. Now you do your second inequality on this same graph. So y is greater than negative 3/4 x plus 3. So again, start with your y-intercept, plot a point at positive 3, use your slope to find the rest of your points. Now be very careful with this slope. Remember that if there is a negative in front of the fraction, you decide where to attach it to. So you either attach it to the 3 and keep the 4 positive, or you attach it to the 4 and keep the 3 positive. You do not attach this negative to both numbers. When a negative is out front, you only attach it to one of them. Okay, so if I attach it to the 3, that gives me a negative 3 and a positive 4 in the denominator. That means that I'm going down 3 and right 4 to my next point. So down 3 again, right 4 to my next point. Okay. Now the opposite is if you attach the negative to the 4. Then my 3 is positive, so I would go up 3, and since my 4 is negative, I would go left 4. Okay, so that'll take you in both of the directions that you need to go. So again, connect those. Now this is going to be a dotted line because our inequality sign was just a greater than. There is no equal to sign with it, so I just use the dotted line. now that that line is graphed, again, you have to pick a test point. So we can still use 0, 0 as our test point here. Plug it into this inequality. So you end up with 0 is greater than 3, which is false. 0 is not actually bigger than 3. So again, my test point is false. So I'm going to shade on the opposite side of this line, which is above it. So everything above it, I'm shading in blue. Now, if you notice, this region right here is where both of the shadings happen at. I have red and I have blue overlapping. So any point in this region is a solution, right? Any point that I picked out of this region, I could plug into inequality 1 and into inequality 2, and it would make them both true. Now, second example. In this one, you have some rearranging to do first, but then it's exactly the same. Okay? So subtract the x to the other side. You have to divide by a -2, which, remember, when you divide by a negative, flips the inequality sign. So this becomes y is less than or equal to negative x divided by a -2, remember, turns into a positive. Negative divided by a negative is positive. So it gives me a positive 1/2 x, and then plus 1 when I divide my constant by the -2. Then that's the line that you're going to graph. So you start at positive 1. Your slope is a positive 1/2. So we're going to go up 1, right 2, up 1, right 2, up 1, right 2, and you keep going. Again, it has an equal to sign underneath of it, so it does get a solid line, and then you pick a test point. When you pick that test point, you get a true statement for 0, 0. So here's my test point at 0, 0. It gives me a true statement, so that means I'm going to shade right over top of that test point. So everything down below this line gets shaded in red. Second inequality, again, needs rearranged. So you're going to have to subtract the 5x to the other side and then divide by a -2. So again, our inequality sign flips here. So you get y is greater than, this gives you a positive 5/2 x and a -3. It's got a dotted line because it does not have an equal to sign with it. So there's our dotted line. Again, we cross at -3. Slope is a positive 5/2, so you're going to go up 5, right 2, up 5, right 2. Your test point. So here's my line, here's my test point. And when I plug in 0, 0, I get a true statement. 0 really is less than 6. So because of that, I'm going to shade, again, directly over top of this. So it's going to be everything above this blue line. So all of this gets shaded in blue, which means this region is where they're overlapping. So that's where your final answers are. Okay? So any point in this region would be considered a solution. Now, when you do these on the pretest and on the practices, it would be really recommended that you use some colored pencils so that you can see where they overlap. Okay? If you're using the colored pencils, it makes it much easier to find that final answer section. All right, one more example. And this is looking at vertical and horizontal lines. So with these ones, remember, if x is, in this case, greater than 4, right? When it's an x value, that means it's crossing through the x-axis at this value. So it's crossing through the x-axis at positive 4. Well, in order for it to cross through the x-axis, it has to be a vertical line. So I have a vertical line at the x value of 4. Now, it's got to be a dotted line because it was just greater than. It did not have the equal to sign on it. Now, with these ones, and you can still use a test point if you want, but you can also really just think about these logically. If this inequality is telling me that it wants all of the x values that are bigger than 4, think about where those would be. If I'm on the x-axis and here is 4, the x values that are bigger than 4 are to the right of it. These are all my positive x values. So these are where my x values are larger than 4, so I'm going to shade everything to the right. Now I have y is less than or equal to -2. So I go to -2 on my y-axis, which remember is your vertical axis, in order for it to cross through this point, it's got to be a horizontal line. In this case, it's a solid line because it was a less than or equal to. Now again, thinking logically, they want all of the y values that are less than -2. So they want all the y values that are smaller than -2. Well, think about your y-axis. Here's -2. These values above it are larger because that goes into my positives. So the y values that are smaller than -2 are going to be below it. So I'm going to shade everything below the line. Again, you can see from the different colors where the red and the blue overlap is in this region here. So any point that falls in this region could be a solution to this system of inequalities. So then it wants you to list an actual solution and not a solution. So an actual solution is any point in that overlapping region. Okay, there's a lot of different answers for this. There's not just one point. So any point that falls in this region could be a solution. Not a solution is any point that's not in this one region. So it could be anywhere else in this graph that is not a solution. It could be just in the blue part. It could be in the part that's just shaded red. Or it could be in this region here that's not shaded at all. Any of those other regions are not solutions. All right, again, this is concept number 4, which is systems of inequalities. Okay, again, same thing as the previous pretest before that. It's just putting 2 of them on the same coordinate plane.